Okay, for interval of convergence and divergence, we know we just use the ratio test. So we take the limit as n goes to infinity of the n plus 1 term compared to the nth term. So this would be n over 3 to the n, x minus 5 to the n. We cancel out things, and so we know this would be left with x minus 5, and then a 3 on the bottom. And so we have x minus 5 over 3. We can pull it in front because it does not have an n. It's not affected by n going to infinity. So we get x minus 5 over 3, and this must be less than 1 in order for it to converge, which means x minus 5 must be less than 3. So our radius is equal to 3. If we make bookends between 3 and negative 3, add 5 to either side, we get 2. And we get 8, and then you must test 2 and 8. So if you test 2, you would have end up having negative 3 to the n over n times 3 to the n. So this is going to cancel, and you'll be left with negative 1 to the n over n, which is alternating, decreasing, and limit equals 0. So this converges by the alternating series test. So this is included, and then if you try 8, you end up getting 3 to the n over n times 3 to the n. This ends up being 1 to the n. P is equal to 1, which is not greater than 1. And so by the p-series test, it diverges. So this is our interval, and this is our radius. Very similar process for the next guy. We take the limit again as n goes to infinity of x minus 2 to the n plus 1 over n plus 1 factorial times n factorial over x minus 2 to the n. And so again we cancel things, and we're left with x minus 2 over n plus 1. And so in this case, if we pull out the x minus 2 and take the limit as n goes to infinity over 1 over n plus 1, we end up getting 0. And 0 is always less than 1. So this is always a true statement. So this means that it converges for all x, so the radius is infinity. Okay, so this is more of a recognition. Hopefully you notice the odd, and you notice the alternating, which means it's sine, and you know that sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, etc. And so you realize, what have they plugged in place of x? They have plugged in 1. So this sum is equal to sine of 1. This, luckily, is a geometric series, and so we can rewrite this as 3 times 3 to the n over 4 to the n, which is the same as 3 times 3 over 4 to the n. And so by the sum, we know the sum is the first term over 1 minus r. And so here, look, n equals 0. So the first term would actually be 3 times 3/4 to the 0, which would be 3. And so 3 over 1 minus the ratio is 3/4. So 3 over a fourth is the same as 3 times 4, and that is 12. Alright, so what is f of x? Hopefully you notice that we see that it is 3 factorial, 5 factorial, 7 factorial, so that looks like sine. And again, sine looks like this. And so this is 4 and 6 and 8. And so what has happened is that each of these powers have increased by 1, and the way we would do that is we multiply through by x. And so this is actually equal to x sine x. Alright, this problem is actually really tricky. I had to think about it for a while. It gives us the derivative. And the thing is if you try to list out derivatives of this and keep on going to get to the 7th term, it becomes really, really ugly really quickly. So we can take the derivative of Maclaurin series, we can integrate them, we can do all these different manipulation techniques. So if we kind of think about taking the antiderivative of this, we can't really take the antiderivative of this by hand. But we know that cosine of x cubed would model cosine of x, right? So cosine of x is equal to 1 minus x squared over 2 plus x to the 4th over 4 minus x to the 6th over 6, etc. Negative 1 to the n, x to the 2n over 2n factorial. Now, if I substitute in x cubed, cosine of x cubed would be equal to 1 minus x cubed squared would be to the 6th, minus x cubed to the 4th would be to the 12th, minus x cubed, plus minus x cubed to the 6th would be 18, and we could keep on going. Alright, and so now we want to find the antiderivative of this. So if I take the antiderivative, I get x minus x to the 6 over 6 times 2, add 1, x to the 7th over, add 1 to the power x to the 7 over 7 times 2 factorial plus x to the 13th over 13 times 4 factorial minus x to the 19th, 19 times 6 factorial. And we could keep on going. So look, here's x to the 7th. And so the coefficient in front of x to the 7th will be negative 1 over 7 times 2 factorial, which is negative 1 over 14. This was a really tricky problem. You just got to be creative. Alright, looking at this one, it says we want to know where, and we get to use our calculator on this problem, and we want to know where this intersects x cubed. So you need to recognize what this is, and if you notice, it looks kind of like e to the x. The reason why you should think e to the x is because you have 2, 3, you don't have the only odd or only even. But notice that the signs of the odd ones are negative, and so that is e to the negative x because the even powers will stay positive. So you realize the function, you just have to recognize it. So set this in y1, and then put y equals x cubed into y2, and then do second calc number 5. And so if you do that, you should get the right answer. So y equals clear e to the negative x, and then x cubed, zoom 6, zoom standard, you can use zoom 6 or zoom 4, or zoom, whichever one you want. Second, trace, number 5, enter, enter, enter. And so this happens at x equals 0.773, 3 decimal places always. Okay, so let's look at this guy. It says a function is defined by the following. Find out the interval of convergence for this power series. Show the work that leads to your answer. So if we find the interval of convergence, that means we use the ratio test. Looking at this right here, so it'd be n plus 2, x to the n plus 1, over 4 to the n plus 2, times 4 to the n plus 1, over n plus 1, and x to the n. And so we try to cancel out some stuff. We would just be left with x, and we'd be left with 4 down here. And so we have x over 4 and the limit of n plus 2 over n plus 1, which is 1. So we have x from 4 must be less than 1, so x must be less than 4. So negative 4, 4, so the interval of convergence. Okay, so then we want to see, we're going to test the endpoints. If you plug back in negative 4 over here, we have n plus 1, negative 4 to the n, over 4 to the n plus 1. And so, let's see. I can pull out a negative 1 to the n plus 1. This is 4 to the n over 4 to the n times 4. So we have n plus 1 over 4. And this is not decreasing because the numerator is always going to be increasing here. You could do the ratio test, you could do comparison tests here and see that it is not going to converge. And if I plug in 4, you're going to get the same thing, it's just not going to be alternating. So you're going to get n plus 1 over 4, which also does not converge. Just the nth term test for divergence is really easy. You take the limit as n goes to infinity of n plus 4 over 4, that's not equal to 0. So both of these diverge by nth term test for divergence. Okay, so this is just, it doesn't include either endpoint. Then it says find the limit as x goes to 0 of f of x minus 1/4. So use this and substitute it in here. So what's going to happen to the 1/4 is they're going to disappear, and so you're going to be left with 2 over 4 squared x plus 3 over 4 cubed x squared plus n plus 1 over 4 to the n plus 1 x to the n, all divided by x. And so if you divide by x, divide by x, divide by x, so looking at this term right here, everything's going to have an x in it, and the x is going to 0, okay? So everything here has an x in it except this first term, and so you're left with 2 over 16. Write the first 3 non-zero terms in the general form for the infinite series that represents the integral from 0 to 1. Okay, so if we integrate from 0 to 1, this function 1/4 plus 2 over 4 squared x plus 3 over 4 cubed x squared n plus 1 over 4 to the n plus 1 x to the n. If we integrate, we're adding 1, so 1/4 x plus 2x squared over 2 times 4 squared plus 3x cubed over 3 times 4 cubed plus n plus 1 x to the n plus 1 over n plus 1, because that's the antiderivative rule, 4 to the n plus 1. Notice the extra cancels out, and so we end up getting 1/4 x plus x squared over 4 squared, x cubed over, etc., all the way until we get the general term, which is this guy. We're supposed to evaluate from 0 to 1, and so if I plug in 1, I get 1/4 plus 1 over 16 plus 1 over 64 plus plug in 1, 1 to the n plus 1 over 4 to the n plus 1, and 1 to the n plus 1, of course, is just 1, so you can just write 1. So that would be your answer. Find the sum of the series determined in part C. Okay, so looking at this is a geometric sum, and the ratio is 1/4. And the first term is 1/4. So it's a of 1 over 1 minus r to find the sum of the geometric series. So it'd be 1/4 over 1 minus 1/4. That's 1/4 over 3/4. So it'd be 1/4 times 4 over 3, so the answer would be 1/3. Okay, and lastly, for review 1, we have the derivatives of a function given to us, right? The third degree Taylor polynomial. So that's pretty simple. You just start off with 3, and then use minus 4x, and then minus 1x squared over 2 factorial, which is just 2, plus 5x cubed over 3 factorial. Use this to estimate f of 1.2, which just entails plug it into your calculator. And so for time's sake, I'm not going to do that. The graph of the fourth derivative, okay, we're going to talk about this on Monday, so I'm going to skip that for now. Write the fourth degree Taylor polynomial for f of x squared plus 2 about x equals 0. Okay, so x squared plus 2. If I, oh, I'm so sorry, up here, I forgot to say it was centered at 2, so that's really important. I'm going to subtract 2, don't forget it's x minus c. It's easy to do. Minus x minus 2 squared over 2 plus 5 times x minus 2 cubed over 3 factorial. Okay, so if we shift this, now this, we're going to be evaluating the derivatives at the same place. So I can just, this is using that idea that we talked about on Tuesday, where it's going to be just a shift of this. And so if I plug in x squared plus 2 in, what happens is you end up just getting, and it's in for x, okay? So it'll be x squared plus 2 minus 2, so you just get x squared. And so basically everywhere you see x minus 2, you're going to write x squared. So it would be 3 minus 4x squared minus x squared over 2. And it's just the fourth degree, so we just go up until we get, oh, x squared squared, because this guy's squared. So 3 minus 4x squared minus x to the fourth over 2. And so for the polynomials, the degree is the degree of the largest exponent on x. So make sure you don't write g of x equals this. G of x does not equal this. Okay, this is, if you want to say p sub 4, that's fine, or you can just throw down the answer and not even label it, and it's a polynomial. And it says use p to explain whether g has a relative max, min, or neither. This right here, you should think the second derivative test. You look at f double prime, and f double prime is the one in front of x squared. So f double prime where are we? Of 0 is equal to negative 4, and that's less than 0. So f is concave. Oh, I'm sorry, I'm doing it in G. G is concave down. And since G is concave, G is the function we're talking about, G is concave down, therefore G has a, think about it, if it's concave down, G has a relative max. Because G prime of 0 equals 0. Notice there's no coefficient in front of x. There's no x here. There's 0x. This means that G prime is 0. And so by the second derivative test. All right. Happy studying.